So in typical fashion, we're looking at the same type of problem, only they become a little bit more complex with each problem. So our first step in this one, we're asked to solve and write the solution in interval notation to this rational inequality. So the first thing we want to do is to factor the denominator. So if we have 1 over x squared plus 2x minus 8 is greater than 0, well, x squared plus 2x minus 8 will factor into x plus 4 times x minus 2, because those two numbers, 4 and negative 2, will multiply to negative 8, and 4 minus 2 adds to 2, the coefficient on x. So that's still greater than 0. So we're not going to have any zeros because our numerator is a constant. It's just the number 1. So we're looking at where it's undefined, and that's where the denominator is equal to 0. So x plus 4 equals 0, or x minus 2 equals 0. We're looking for our critical points, so we look for where it's 0 and for where the expression is undefined. So x equals negative 4 or x equals 2. So we'll draw our number line and look at our critical points. So 0, negative 1, negative 2, negative 3, negative 4. We know there's a critical point there. And then 1, 2, we know that there's a critical point there as well. So this breaks us up into the intervals: negative infinity, negative 4, negative 4, 2, and 2 to infinity. And notice that our final solution is not going to have a square bracket. It's not going to be inclusive because our inequality is strictly greater than. So now we will test a point in each one of these intervals. So let's just use x equals negative 5 for our first interval. X equals, let's just go with 1 for our second interval. And x equals 3 for our third interval. We're just choosing a value that's in each interval, and then we'll test that. And again, you can do this the way that you've seen in the written out examples with your number line. Look at each one of the factors in the denominator and then look at what their product is. I'm just simply going to substitute into the original expression, and then look at what the sign is. So x equals negative 5. With that, we have 1 over negative 5 squared plus 2 times negative 5 minus 8, which equals 1 over 25 minus 10 minus 8, which equals 1/7. So in this interval, it's going to be positive, which is what we wanted. We want it to be positive. So we know that interval is going to be part of our solution. At x equals 1, we have 1 over 1 squared plus 2 times 1 minus 8, which equals 1 over 1 plus 2 is 3 minus 8 is negative 5. So that's going to be negative 1/5. That's negative, so that's not going to be part of our solution. And then finally, x equals 3 for the interval 2 to infinity. So we have 1 over 3 squared plus 2 times 3 minus 8, which equals 1 over 9 plus 6 minus 8, which equals 1 over 7, which again is positive. So non-inclusive because our inequality is strictly greater than. It doesn't include equals. And we're going to say that the solution is the first interval, negative infinity, negative 4, combined with, so union, our last interval, to infinity. Because on these intervals, if we substitute a value into our rational expression, it's going to be greater than 0.